Good morning. In the earlier lecture, we talked about Fourier transform of derivatives of functions f of t and Laplace transform of derivatives of functions f of t. After that, let us go for inverse Fourier transform. You know Fourier transform? Fourier transform is given this expression. Inverse Fourier transform will be given by an expression f of t is equal to f inverse of s. We shall use this formula and try to get inverse Fourier transforms of some given functions. For this you need the formula for inverse Fourier transform. Let me write the formula here so that we can use these formulas for getting inverse Fourier transform of given functions. The formulas are these are some formulas we may require while solving inverse Fourier transform. Let us go for the first problem. First problem of inverse Fourier transform. And that is Let us try to get inverse Fourier transform of x of omega. Omega is the frequency reciprocal of the time. X of t, function of time. X of omega, function of frequency. Fourier transform, inverse Fourier transform. Fourier transform, we have f of t is the function of time. Inverse Fourier transform, inverse to the Fourier transform. And inverse of time is frequency, x of omega. So, we are asked to find inverse Fourier transform of x of omega, which is given by j omega plus t divided by j omega plus 1 bracket square. This is for x of omega is equal to j omega plus 1 plus 2 divided by j omega plus 1 square 1 plus 2 3. This is for the j omega plus 1 divided by j omega plus 1 square plus 2 divided by j omega plus 1 square. J omega plus 1, j omega plus 1 square, 1 will get cancelled. And we have 1 divided by j omega plus 1 plus 2 divided by j omega plus 1 square. This is what? X of omega. What we want? We want f of t. F of t meaning f inverse of this. F inverse of x of omega. That's what we have to do formula. For 1 by j omega plus 1 by a plus j omega. Instead of e to the power minus at, what become e to the power minus t. So let me first write this. X of omega is equal to e to the power minus pt into f of t plus j omega plus 1 square 2 times e to the power minus t f. According to first formula, this will be e to the power minus t f of t. This will be 2 times e to the power minus t f of t. And now, inverse of Fourier transform is f inverse of x of w is equal to f inverse of so inverse is already obtained. Now this is for the just remember this. 2t t to the power minus 80 f of t is 1 divided by a plus j omega square. 2 divided by 1 plus j omega. E to the power instead of minus 80 simply e to the power minus 80. And now you can take this count. If e to the power minus t f of t is taken common in the other bracket, from this 1 is left plus from this 2t is left. So this is Fourier inverse transform or inverse Fourier transform of this frequency function. X of omega is equal to j omega plus 3 divided by j omega plus 1 square. Then let us go for the second problem on inverse Fourier transform, and that is x omega is equal to 5 plus 2j omega divided by j omega square plus 5j omega plus 6. X of w is equal to 5 plus 2j omega divided by j omega square plus 5j omega plus 6, and we have to get inverse Fourier transform of this solution. This x of omega is equal to 5 plus 2j omega divided by 5, 2 plus 3, 2 into 3 is 6. So it is simply j omega plus 2 into j omega plus 3. This is equal to 1 divided by j omega plus 2 plus 1 divided by j omega plus 3. 1 into j omega plus 3 plus 1 into j omega plus 2, 2 plus 3, 5, j omega plus j omega plus 2 j omega. So the given function x of omega is equal to 5 plus 2j omega divided by j omega square plus 5j omega plus 6 can be converted to this. And after this we can go for the inverse Fourier transform, and that is f inverse of x of omega is equal to f inverse of 1 divided by j omega plus 2 plus f inverse of 1 divided by j omega plus 3. A plus j omega. That is, this is a, this is j omega. So it will be what? E to the power minus 2t f of t. This is equal to e to the power minus 2t into f of t plus e to the power minus 3t If f of t is taken common, it will be f of t into in the bracket e to the power minus 2t plus e to the power minus t. This is the inverse Fourier transform of the given function x of omega is equal to pi plus 2j omega divided by j omega square plus pi j omega plus 6. Let us go for one more problem for inverse Fourier transform. This is generally used in the fields where time functions or frequency functions are used. So, in telecommunication, in telephones, etc., everywhere such functions will be utilized. The next problem is x omega is equal to omega square plus 21 divided by omega square plus 9. X omega is equal to omega square plus 21 divided by omega square plus 9. Let us see how to solve this problem. We have to split this into standard form. Let us see how to split this. Divide this by this. Omega square plus 21 divided by omega square plus 9. Omega square plus 9 ones are omega square plus 9 minus 0, 21 minus 9, 12. Okay, so this may be further written as 1 divided by omega square plus 3 square plus 12 divided by omega square plus 3 square. We may have formula of this type somewhere. Yes, here we have formula of this type. Let me put this further as 1 divided by omega square plus 3 square plus this value can be split as 2 times 2 into 3 divided by omega square plus 3 square. 2 is a 4, 4 is a 12. And then f inverse of x of omega is equal to f inverse of 1 divided by omega square plus 3 square plus 2 times f inverse of 3 into 3 divided by omega square plus 3 square. This is equal to, when numerator is 1, the equation will be, no, we have to go for this 2 is not there. So this will be 3 divided by omega square. Sorry. For this, what I have to do? In the first case, we will get 2 will be there. So I am making precise. 1 is there. F inverse of 1 is delta t, and 3 is e to the power minus 3 modulus of t plus 2 times e to the power minus 3 modulus of t. So this is the inverse Fourier transform of the third problem. Something wrong is right. Only one is here. This is not here. Simply one is here. Question is only here. So it is simply this one. 1 plus 12 divided by omega square plus 9. We have written here 1 divided by omega square plus 9. That was wrong. It will simply 1 plus 12 divided by omega square plus 3 square. That is omega square plus 9. It is further splitted into 2 into 2 into 3, and then f inverse of 1 delta t, and this 2 times f inverse of 2 into 3 omega square plus 3 square, that is 2 times e to the power minus 3 modulus of 3. So this is the correct answer of the inverse Fourier transform of this function x of omega is equal to omega square plus 21 divided by omega square plus 9. We can go for more problems, but I think we stop here, and in the next lecture we shall go for inverse Laplace transform. Thank you.